We will continue to explore the use of thermal reaction norm of sex ratio, and now we will begin to talk about field data. In the previous videos, we have done several estimations and we have been able to conclude about some points. We have shown that we should use a Bayesian model to estimate the thermal reaction norm for sex ratio, and this thermal reaction norm for sex ratio was not a true thermal reaction norm, but rather a population equivalent of thermal reaction norm. We have tested different models, Flexit or Stairs model, and we have not been able to choose between these two models with Lepidopteris olivacea data. We have also tested for RMU effect, both random and fixed effect. At this stage, we cannot conclude that this conclusion can be generalized or not. Perhaps for other species, RMU effect could be detected or different model can be selected. Always, I conclude the previous video with it is important to remember that the fitted pattern must not be used to estimate sex ratio from field. The sex ratio thermal reaction norm only works for constant incubation temperatures. We will see the reason now, and it will be the beginning of transition toward how to estimate sex ratio from field. The naive use of the thermal reaction norm that we have fitted previously is done as follows. We can calculate the average temperature within one nest, and we search the sex ratio obtained in the thermal reaction norm of sex ratio fitted with constant temperature, and when using this average temperature. We will show that it is wrong for two reasons. The first reason is that the average temperature is a measure of temperature during all development, whereas sex determination is sensitive to temperature of incubation during only a specific period of development, named the thermosensitive period of development for sex determination. The abbreviation is TSP. We will explore this point in more details in future video. Then, the average temperature during all development cannot be a correct measure for the effect of temperature for sex determination because the temperature only acts during a specific period of development. Another point is the use of average temperature by itself. Imagine that incubation was done at 32 degrees Celsius during all incubation, for example 50 days. Then the average temperature will be obviously 32 degrees Celsius, and we see from this pattern of thermal reaction norm that at 32 degrees Celsius only female will be produced. As we use constant incubation temperature, we can use this pattern. But now, in reptiles, the rate of development of embryos is dependent on incubation temperature. Then imagine that you incubate eggs at so low temperature, for example 10 degrees Celsius, that no development can occur because this is too low, but if it is for a very short time, the embryo can survive. Imagine it will survive. For embryo, as no development occurs at 10 degrees Celsius, the sex determination will be all female because nothing happened at 10 degrees Celsius. The incubation at 10 degrees Celsius does not count for embryo metabolism. This has been proposed initially by Claude Piot in 19 1982 and perfectly demonstrated by seminal work of Arthur George and collaborators in 1989 and 1994. Let's take an example. Imagine the incubation was done at 32 degrees Celsius except for 5 days at 10 degrees Celsius where no development occurs. Then the incubation duration will be 55 days. The average temperature will be only 32 for 50 days, 5 days 10 degrees Celsius. Then the average temperature will be 30 degrees Celsius. For 10 days at 10 degrees Celsius, the average temperature will be 28.33 degrees Celsius. All these embryos will be 100% feminized because at 10 degrees Celsius nothing happens. But the CTA predict 100% male at 28.33 or mixed sex ratio at 30 degrees Celsius. Then the average temperature within a nest cannot be a correct constant temperature equivalent. Another way to show that the average temperature cannot be a correct CTE, a correct proxy of temperature to describe sex determination, is shown here. At the top, you have the average temperature recorded in different field nests in x-axis, and in y-axis you have the observed sex ratio. You see the point are the observed sex ratio, and we fit a model, a flexit model of on this graph. This is what some person have named field thermal reaction norm for sex ratio. Now compare this field thermal reaction norm for sex ratio with the true thermal reaction norm for sex ratio obtained at constant temperature at the bottom. You see that clearly the two graphs does not match. The model fitted with field data is not at all equivalent with the model fitted with constant temperature. This field thermal reaction norm for sex ratio has been proposed to be the solution to estimate sex ratio from field. However, this pattern is dependent on the variance of temperature in nest. The higher are the variance of temperatures, the more the pattern will be shifted to the right toward higher temperatures. The reason, again, is that more development occurs at higher temperatures than at lower temperature. Up to a certain threshold, when too high temperatures become subletals, we will see this in the next video. Thus, there is not one general pattern of thermal reaction norm of sex ratio fitted from field temperatures, but an infinite number depending on the variance of temperature. In conclusion, any measure of temperatures taken during all incubation cannot be a correct measure of temperature effect for sex ratio because temperature effect occurs only during a certain period of development, named the thermosensitive period of development for sex determination. The average temperature experienced by embryos during incubation is not a correct constant equivalent temperature to be used to estimate sex ratio using a fitted thermal reaction norm at constant temperature for sex ratio. There is not an equivalent pattern of the thermal reaction norm for sex ratio fitted using average field temperature. It does not exist. There are an infinite number of thermal reaction norms for sex ratio. It is absolutely not possible to use such kind of pattern in general situation. See you.